In this lesson, we will be learning about the Pythagorean Theorem and its converse. So our first theorem is the Pythagorean Theorem. I'm sure you've already had the Pythagorean Theorem in previous math courses. It's been used in algebra problems at least, I'm sure. But here we're going to apply it to coordinate geometry and take it a little further in looking at its converse and how to use it to determine if a triangle is obtuse or acute. So the Pythagorean theorem states that if a triangle is a right triangle, then the sum of the squares of the lengths of the legs is equal to the square of the length of the hypotenuse. Remember, the hypotenuse is the side that is opposite the right angle in a right triangle, and the other two sides are the legs that form the right angle. So in this diagram, so we have the square of a leg plus the square of a leg is going to be equal to the square of the hypotenuse. In this diagram, that's going to be a squared plus b squared is equal to c squared, which is probably how you have learned this. The one thing I want you to do at this point, though, is it will make it a lot easier on you with the other theorems we have in this lesson, if you will reverse this, which is going to be the same thing. So I could also state this as c squared equals a squared plus b squared. If you will remember it this way in that order, it will help you in determining if a triangle is obtuse and acute, and you'll see that in this lesson. So let's look at what a Pythagorean triple is. A Pythagorean triple is a set of non-zero whole numbers, a, b, and c, that satisfy the equation c squared equals a squared plus b squared. So it says non-zero whole numbers, but I prefer to really call it positive integers, because you're not going to have a leg of a triangle that can be a negative number. So it can't be a negative integer, wouldn't make any sense, but it can be a positive and has to be positive. So if you multiply those together in a Pythagorean triple by the same whole number, so let me scroll up. So if you multiply each number in the Pythagorean triple by the same whole number, then the three numbers will also result in form of a Pythagorean triple. There are about 4 sets of common Pythagorean triples that you'll see on standardized tests like the ACT in particular. They like to use 3, 4, 5 Pythagorean triple. All that means is that you have a right triangle. Of course, the longest side is always the hypotenuse, so the hypotenuse would be 5 and the legs would be 3 and 4. So those are 3 positive integers that satisfy the Pythagorean theorem, so they're called a Pythagorean triple. If I multiplied all of those by 2 and got a 6, 8, 10, that would still be a Pythagorean triple. So that's what it's saying. You can multiply it by any whole number and you're still going to form another Pythagorean triple. So there's an infinite number of Pythagorean triples, because you can infinitely multiply them by other integers and you're always going to get another triple. Another set of these, you need to memorize these sets of Pythagorean triples. The 3, 4, 5. Another set is a 5, 12, 13. Another common set is an 8, 15, 17. And then a fourth set that you need to learn is the 7, 24, 25. So that just means that in a 5, 12, 13, the hypotenuse is 13 and the legs are 5 and 12. In the 8, 15, 17, the hypotenuse is 17 and the legs are 8 and 15. And then the 7, 24, 25, the hypotenuse is 25 and the legs are 7 and 24. So those are just 4 common Pythagorean triples that it would benefit you to memorize so that you can work ACT and SAT problems faster, for one thing. So let's go down and look at the converse of the Pythagorean theorem. The converse of the Pythagorean theorem is just a way to prove whether a triangle is a right triangle or not. So it states that if the sum of the squares of the length of 2 sides of a triangle is equal to the square of the length of the third side, then that triangle is a right triangle. So in this triangle that's pictured here, if c squared is equal to a squared plus b squared, then you can say that triangle ABC is a right triangle. The next theorem that's related to this, we could call it the obtuse triangle theorem. Let's just write that down there. Obtuse triangle theorem. That's what we could call that one. It says that if the square of the length of the longest side of a triangle is greater than the sum of the squares of the length of the other 2 sides, then that triangle is obtuse. So here in this triangle, if c squared is greater than a squared plus b squared, then the triangle is obtuse. So this is where it's beneficial to have the c squared on the left side of the inequality and the a squared plus b squared on the right side, because if the sign that goes between them is a greater than symbol, then it's obtuse. But in the next theorem, which we could call the acute triangle theorem, it says that if the square of the longest side of a triangle is less than the sum of the squares of the lengths of the other 2 sides, then the triangle is going to be acute. So here, if c squared is less than a squared plus b squared, then the triangle is going to be acute. So let's apply this to some problems on the right side. In problem 1, it's using the Pythagorean theorem, and it says, what is the length of the hypotenuse of triangle LMN, and do the side lengths of LMN form a Pythagorean triple, and explain why, or why not. So once again, the side length opposite the right angle is always going to be your hypotenuse. So c squared equals a squared plus b squared is the Pythagorean theorem. It doesn't matter which one of these is, the 8 and the 15, it doesn't matter which one is a and which one is b, because you're just squaring them and adding them, so the order doesn't matter. So we have c squared is equal to 8 squared plus 15 squared, which is 64 plus 225, which is 289. Solve for c by taking the square root of both sides, and that is a perfect square, 289. So c is equal to 17. And is it a Pythagorean triple? Yes, it is, So yes, 8, 15, 17 is a Pythagorean triple because all three sides are positive integers or non-zero positive whole numbers. Problem 2, scroll down. Problem 2, you're going to find the value of x and express your answer in simplest radical form. So once again, we're going to use it, but we have a right triangle, so we know that the Pythagorean theorem applies. C squared equals a squared plus b squared. So which value goes in for c? C is always the hypotenuse opposite the right angle. So it has to be the 16. So 16 squared is equal to x squared plus your other leg is 10 squared. So you got 256 is equal to x squared plus 100. Subtract the 100 from both sides. You got 156 is equal to x squared. Take the square root of both sides, and x is equal to the square root of 156. Well, it asks us to express the answer in simplest radical form. And 156, square root of 156 is the same as, that's 4 times 39. So you're looking for a perfect square factor of 156, which is 4. 4 will go into 156 39 times. So I can take the square root of the 4 out from under the radical. Take the square root of that. Square root of 4 is 2. Leave the 39 under the radical sign, and that is your simplified radical form of your answer. Problem 3. This is a common type of problem you might see on a standardized test like the ACT. It says Jamal leans a 12-foot ladder against the side of a house. The base of the ladder is 4 feet from the house. So to the nearest tenth of a foot, how high on the house does the ladder reach? So just sketch a diagram of this. So we have the house. We have a 12-foot ladder leaning against the house. And it's 4 feet away from the house. And so we want to know how high on the house does the ladder reach. So we have a right triangle. We know the Pythagorean theorem applies. So c squared is equal to a squared plus b squared. Once again, your c squared is your hypotenuse, which is opposite the right angle. So c squared is 12 squared. And that's going to be equal to the x squared plus 4 squared. So that's 144 is equal to x squared plus 16. Subtract the 16 from both sides, you get 128. We need to solve for x by taking the square root of both sides. And it wants this to the nearest tenth of a foot. So that means you can just plug this one into your calculator. You don't have to find the simplest radical form. The square root of 128 is going to be 11.3 feet. Is how high up the building the ladder is going to reach. The next problem, problem 4, identifying a right triangle. So the question is, you got a triangle that has side length of 12.5, 30, and 32.5. Is it a right triangle or not? And explain why or why not. So here's where, this is the converse of the of the Pythagorean theorem. So you take the longest side, which is 32.5, and you're going to put that in for C. we don't know if these are going to be equal or not. So is c squared going to be equal to a squared plus b squared? So we're going to put the 32.5 in for c squared because that's the longest side. It would be the hypotenuse if this is a right triangle. And the other two, it doesn't matter the order you put them in. So 12.5 squared plus 30 squared. Put those in for A and B. If you square 32.5, you're going to get 1056.25. And if you square 12.5 and 30 and add those together, it does equal 1056.25. So they are equal, and so the answer is yes, it is a right triangle because of the Pythagorean converse. Last problem is classifying a triangle. So in this problem, it gives you side lengths, 3 side lengths of a triangle, and you're supposed to classify it as acute, obtuse, or right. So again, you're going to use your c squared on the left side and the a squared plus the b squared on the right side. But the question is, what goes in between? Is it if it's an equal sign, then it's a right triangle. If it's a greater than sign, it's an obtuse triangle. And if it's a less than sign, it's going to be an acute triangle. So let's plug in the numbers. The largest side they give us is a 12, so that goes in for your C. The other two lengths are 4 and 9, so that's 4 squared plus 9 squared. So we have 144 on the left side, and we have 16 plus 81 on the right side. So 144 on the left side, 16 plus 81 is 97, and so 144 is greater than 97, so that means it's an obtuse triangle because the square of the longest side is greater than the sum of the squares of the other two sides.